what is Internet of Things and overview of Internet of Things. Internet of Things refers to the set of devices and the systems that are interconnect real-world sensors, actuators to the internet. Or Internet of Things is a network of devices which can sense, accumulate, and transfer data over the internet without human interventions. So this Internet of Things must have some characteristics. The first one is connectivity, where things in the Internet of Things should be connected to the infrastructure, and the connectivity is an important requirement for an Internet of Things infrastructures. Anyone, anywhere, anytime, connectivity should be guaranteed in the Internet of Things infrastructure. Without connection, nothing makes sense. I say that things are connected and they need connectivity. The second one is intelligence and identity. This is an artificial intelligence where the smart objects, the extraction of knowledge, what is to be inferenced from the generated data as very important. Sensors generate data. The data has to be interpreted properly. Each Internet of Things device has an unique identity. Remember, IP address. This identity helpful in tracking the equipment in at times to query the status. The third one is scalability. The number of things or devices getting connected to the Internet of Things infrastructure is getting increased day by day. Hence, an Internet of Things setup shall be capable to handle the massive expansion. Also, the data generated shall be massive and it should be handled appropriately. The fourth one is dynamic and self-adapting or complexity. The Internet of Things device should be dynamically adapt itself to the changing context. Assume a camera meant for surveillance, it may have to work in different conditions as different light situations, morning, afternoon, night. The fifth one is architecture. Architecture cannot be homogeneous in nature. It should be hybrid, supporting different manufacturer product to be in the Internet of Things networks. The last not the least, safety. Having got all the things connected to the internet, the personal data, if sensitive, is under threat. Hence, securing the data is a major challenge. Not only data security, the equipment getting involved in Internet of Things network is huge. Hence, personal safety is also to be considered, privacy with protections. So the definition of Internet of Things, the networking of smart objects, meaning huge number of devices intelligently communicating in the presence of Internet protocol that cannot be directly operated by human being but exist in a component in buildings, vehicle or environments. Or the Internet of Things is a networking of smart objects in which smart objects have some constraints such as limited bandwidth, power, processing, accessibility for achieving interoperability among smart objects. Internet of Things is a framework of all things that have representation in the presence of Internet in such a way that the new applications and the service enable the interaction in the physical and the virtual world in the form of machine-to-machine communications in the cloud. The interaction of every object computing device through the Internet that enables the sending and receiving of useful data. So Internet of Things is where the sensors come together into the networks, the data And finally, the service is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifier and the ability to transfer data over the network without requiring human to human or human to computer interactions. In Internet of Things, a thing is Internet of Things can be a person with a heart monitoring plant, a farm animals with biochips transponder, an automobile that has built-in a sensor to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an IP address and able to transfer data over a network. The Internet of Things, four key technological enablers are radio frequency identifier technology used for tagging the things, the sensors technology used for sensing the things, the smart technology used for thinking the things, nanotechnology used for shrinking the things. Generally speaking, Internet of Things is just more than machine-to-machine communications, with technologies include wireless sensors network, sensor network, 2G, 3G, 4G, GSM, and all this with microcontroller and microprocessor extra. There are four main components of Internet of Things systems. The first one is the things itself or devices. The local network. This can be include gateway, which translates proprietary communication protocol to the internet. The internet or the global network, back-end service, enterprise data system or PC, and the mobile devices. There are of course two key aspects of Internet of Things: the devices themselves and the server-side architecture that supports them. In fact, there is often the third category as well. In many cases, there may be low-power gateways that perform aggregations, event processing, bridging, and etc. that may be located between the devices and the wider internet. There are three types of devices in Internet of Things. The smallest devices have embedded 8-bit system on chips controllers, or the small home routers, and the derivative of these devices commonly just run cut down or embedded Linux platforms such as OpenWRT or dedicated embedded operating system have very limited 32 bits Atorus and ARMS chips. The most capable of Internet of Things platforms that are fully 32-bit or 64-bit computing platform systems such as Raspberry Pi. The Picklebone may run full Linux operating system and other suitable operating systems such as Android. Internet of Things communication mechanisms. Communication between devices and the internet or to gateway includes many different models. Direct internet or Wi-Fi connectivity using TCP or UDP. This we will look at the protocol for this, and the other one is which can interconnected through the gateway or other half devices like Bluetooth, low energy, near field communication, ZigBee, or other mesh radio network, SRFS point-to-point radio link, UART, or serial lines, SPI, or I2C wired bus. So the ability to connect a large number of heterogeneous Internet of Things elements should be high level, real-time awareness with low latency, ability to secure all traffic flows, programmability for application customizations, traffic monitoring and management at the device level, low-cost connectivity for large number of devices. These are an overview of Internet of Things. Next, we will see the history of Internet of Things. Thank you. A report suggested it all started in 1900, where 300,000 desktop computers were connected to the internet. In 2000, it grew to 300 million desktop computers, laptops to connect to the Internet of Things. In 2016, you guys can tell this about 2.5 billion mobile phones are connected to the internet, and so in 2020, all devices about more than 15 billion devices connected to the internet, about 4 billion navigator system, about 500 million wearable watch, and 10,000s of million implement in human. So the internet, the history of the internet starts somewhere, was coined by Kevin Ashton in the presentation of Procter Gamble in 1999. He's a co-founder of MIT Auto ID Lab. He pioneered a request radio frequency identifier used in a barcode detector for supply chains management domain. Although Ashton was the first man to mention of the Internet of Things, the idea of connected device has been around since 1970. Under the Monke's embedded internet and the pervasive computing, the first internet appliance, for example, was the Coca vendor machines at Carnegie Mellon University at early 1980s. Using the web, programmers could check the status of the machines, determine whether there would be a cold drink awaiting them should they decide to make the trip to the machines. So in the pre-internet era, most of the human-to-human communication was through fixed line and a mobile telephone using telegraph. Dawn of the internet, or the emergency of the internet, or with the origin of the internet, the world changed at once. We could be continents apart and still share vital information at just a click of button. Internet of people. After the invention of blogging, social media began to explode in popularity. Sites like MySpace in 2003, Facebook in 2004, LinkedIn promotion in the early 2000s, and YouTube also 2005, creating an entirely new ways of people to communicate and share with each other across great distance. Internet of Things is nearly all data available on the internet today was first captured and created by human beings. The problem is people have limited time, attention, and accuracy, which means they are not very good at capturing data about things in the real world. So, if you had computers that knew everything there was to know about things, using data they gathered without any help from us, we could be able to track and count everything and greatly reduce waste and loss and costs. This is what gave birth to Internet of Things. Internet of Things has evolved from the convergence of wireless technology, micro electromechanical systems, microservice, and the internet. The convergence has helped tear down the silos between operational technology and information technology. This convergence enables unstructured machine-generated data to be analyzed for insight to drive improvements. Internet of Things evolved from machine-to-machine communication. That means machine connecting to each other via the network without human interactions. Machine-to-machine refers to the connecting device to the cloud, managing and collecting data. Machine-type communications describes any network where two or more devices exchange data directly and without user interfaces. Taking machine-to-machine to the text level, Internet of Things is a sensor network of billions of smart devices that connect people, systems, and other applications to collect data, share data. This is the foundation of machine-to-machines, offers the connectivity that enables Internet of Things. So this is the history of Internet of Things. Next, we will see what is the advantage and the disadvantage of Internet of Things. Thank you. Challenges of Internet of Things. There are key challenges of implementation today that need to be addressed before the mass adoption of Internet of Things can occur. That include especially the privacy and the security, which refers to the security issue at different layers of Internet of Things. Trust and the quality of information is shared in information models. A secure exchange of data between Internet of Things devices and the consumer of their information. Protection mechanisms for vulnerable devices. And the cost versus usability. Reduction cost of devices and the mechanism to use devices is expected. And interoperability with numerous sources of data and the heterogeneous devices that use of standard and the interface between these devices need to become important. As there is a data management, the volume of generated data and the process involved in the handling of those data become critical. Also, the device energy consumption levels, how to interconnect things in an interoperable way while taking into account the energy constraints. The communication between devices takes the most energy. So, in order to this, there is also Internet of Things some advantages because it improves the customer engagement, technology optimizations, and reduce wastes, enhance data collections, sensors to do data, and as well as there is also some drawback, increase the security concerns. Also, this is also one of the challenge. Big data management is issue handling huge number of data. The highest chance of system corruptions. The device can be corrupted maybe, and the device interoperability also multi-different device vendors with accepted standards. These are some challenges and the pros and the cons of Internet of Things. Going to see what is the Internet of Things architecture. This architecture is about consists of 7 layers. The first one is the sensor input to the microcontroller, microprocessor, or data collections happens here. The sensors there are three types of sensor. Motion sensor measures the change in motion as well as the orientation of the devices. There are two types of motion. One can observe a device linear and angular motions. The linear motion is referred to the linear displacement of the Internet of Things device, while the angular motion refers to the rotational displacement of the devices. And the second one is the environmental sensors such as light sensors, pressure sensors embedded in Internet of Things device to sense the change in environment parameters in the device peripherals. The primary purpose of using environmental sensor in Internet of Things is to help devices to take autonomous decision according to the change a device peripheral. For instance, environmental sensors are used in many applications to improve user experience. The third one is position sensors. This device deals with the physical position and the location of the devices. The most common position sensor used to Internet of Things devices are magnetic sensors, global positioning systems. Magnetic sensors usually used to digital compass. They help to fix orientation of device display on the other hand. The other one is processing and control action layers, microcontroller processing. These are where the data is for processing, especially locally. Microcontrollers, ordinary or Raspberry, Linux, Android. The third layer is hardware interface layers, which is component for communications, maybe USB, serial, parallel, standard. The third layer is an interface layer through which the communication is directly taken as or going to classification for short range or low bandwidth, long range, and like Wi-Fi, Bluetooth. These are especially used for connections. The fourth one is session or message layers, where there is a content like MQTT, HTTP, FTP, SFTP, SSH protocol. The other is user experience or visualization layers, technologies, object-oriented, procedures-oriented, like database management system, SQL. Finally, the seventh layer is application layers, smart home, smart city, smart agriculture, and so forth. Internet of Things ecosystem consists of web-enabled masters, smart device that uses embedded processors, sensors, and the communication hardware to collect, send, and act on the data they acquire from their environments. Internet of Things device shares sensor data they collect by connecting an Internet of Things gateway or other edge devices, where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes this device communication with other related devices and act on the information they get from the one another's. Remember that Internet of Things technology is a built system capable of autonomous sensing and responding to stimuli from the real world without human interventions. We therefore need to develop process flow or definite framework over which an Internet of Things solution is built. The Internet of Things architecture to be discussed or generally comprised of 4 stages. The first stage is sensors and actuators. A thing in a context of Internet of Things should be equipped with sensors and actuators. This gives the ability to emit, accept, and process signals. The second stage is data acquisition system. The data from the sensors start in analog, from which need to be aggregated and converted into digital stream for further processing. This stage performs this data aggregation and the conversion functions. The third stage is edge analytics or edge computing. Once Internet of Things data has been digitalized and aggregated, it may require further processing before it enters the data centers. This is where edge analytics comes in. The fourth one is cloud analytics. Data that needs more in-depth processing gets forwarded to physical data centers or cloud-based systems. Here, as you see on the graph, sensor actuators, wired or wireless, internet gateway or data acquisition systems or data aggregations, HIT analytics, pre-processing, data center, cloud analytics management architectures. Most researchers agree on conventional architectures for Internet of Things that include the following layers: perception layers, network layers, and application layers. Some other latest variants, including Internet of Things latest architectures, add support layers that lays between the application layers and the network layers. Support layers consist of fog computing and cloud computing. Hence, Internet of Things architecture consists of different layers of technology supporting Internet of Things. It serves to illustrate how various technology relate to each other and to communicate the scalability, modularity, and the configuration of Internet of Things deployment in different scenarios. The latest agreed upon Internet of Things architecture is composed of smart devices, sensors layer or perceptions, gateway on the network layers, management service layers, application layers. A smart device or sensor layers lowest layer made up of smart object integrated with sensors. The sensors enable the interconnection of physical and digital world along real-world information to be collected and processed. Various types of sensor for different purposes. Sensors have the capacity to give measurements such as temperatures, air quality, speed, humidity, pressures, flow, movement, and electricity. Most sensors require connectivity to sensor gateways. This can be in the form of local area networks such as Ethernet, Wi-Fi connections, personal area networks such as Zigbee, Bluetooth, and ultra-wideband. For sensors that do not require connectivity to sensor aggregate their connectivity to back-end servers, application can be provided using wide area networks such as GSM, GPRS, and LTE. Sensors that use low power and low data rate connectivity typically form networks commonly known as wireless sensors networks. Massive volume gateway and network layers. This is the second one. Massive volume of data will be produced sensors, and this requires robust and high performance wired or wireless network infrastructures as transport mediums. Current network IP-based, often tied with a very different protocol, have been used to support machine-to-machine network and their applications, with the demand needed to serve a wide range of Internet of Things service applications such as high-speed transaction services, context awareness applications. This is multiple network with various technology and access protocol are needed to work with each other in heterogeneous configurations. Any protocol that carry IP packet has advantage over all others. The connectivity requirement of Internet of Things devices so diverse that single technology cannot meet all the range, power, size, cost requirements. The importance of IP to the Internet of Things does not automatically mean that the non-IP networks are useless. It just means that non-IP network requires a gateway to reach the Internet. This network can be in the form of private, public, or hybrid models are built to support the communication requirement for latency, bandwidth, and security. Various gateway, microcontroller, microprocessor, gateway network, Wi-Fi, GSM, GPRS. A smart Internet of Things gateway is implemented to provide data processing, local web servers, and cloud connections. After gateway receives the data from the wearable sensors, it will forward the data to Internet of Things cloud for further data storage, processing, and visualizations. This layer also ensures unique addressing and routing ability to unified integration of uncountable devices in a single cooperative network. Various types of technology have contributed to this phenomenon, such as wired, wireless, and satellite technologies. The implementation of 6 low WPN or Low Power Personal Area Network over IP version 6 protocol to hard IP version for unique addressing of devices. Also important developments. IP version 6 is a key for Internet of Things. Addressing schema provide more addressing than there are gain to send on Earth. The management service, this is the third one. The management service renders the processing of information possible through analytics, security controls, process modeling, and the management of devices. Service may include applications and the support service often provided by cloud for computing technologies. Management service layers features business and processing rule engines, support the formulation of decision logic, and trigger interactive and automated process to enable more responsive Internet of Things. Analytics. Various analytic tools are used to extract relevant information from massive amount of raw data and to be processed at much faster rate. Two types. In-memory analytics allow large volume of data to be cached in a random access memory rather than stored in physical disk. Streaming analytics allow analysis of data considering data in motion is required to be carried out in real time so that decision can be made in a matter of seconds. Data management is ability to manage data information flow. With the data management in the management service layer, information can be accessed, integrated, and controlled. Data filtering techniques such as data anonymization, data integrations, data synchronizations are used to hide the detail of information while providing only essential information that is usable for the relevant applications. Management service features security must be enforced across the whole dimension of Internet of Things architectures, right from the smart object layer all the way to the application layers. Security of the system prevents system hacking and compromising by unauthorized persons. This reduces the possibility of risky. So illustration of Internet of Things scenario, simplified representation of Internet of Things network compasses in the device gateway communication link. Internet of Things application service. Typically scenario involves this entity includes the device collecting data from an environment, temperatures, luminosity, movement, and reporting. If it's a provision entity hosting by an IoT platform service provider, the different communication technology and gateways must have means to device provisioning, administration, monitoring, diagnostic, important for traveling replication, and corrective measures. An ideal solution will provide means for managing all devices from one dashboard. So this is the Internet of Things architecture. Internet of Things is very important. Nowadays touches every industry, including healthcare, finance, retail, manufacturing. It helps people live and work smarter, smart home, smart city, smart kitchen. Smart cities help citizens reduce waste and energy consumptions. To provide business with real-time looking into how their company system really work, delivering insight into everything from the performance of machine to supply chain logistic operations. Connected sensors are even used for farming to help monitor crop and cattle yield and predict growth pattern. It touches every industry, enable to company to automate process and reduce labor cost, cut down waste, and improve improves service delivery, less expensive to manufacture delivery goods, as well as offering transparency into customer transactions. There are numerous real-world applications of the Internet things range from consumer and enterprise to manufacturing in the industry. So there are some smart energy, smart city, smart health. Let us see some application domains of across this Internet of Things. So the Internet of Things and smart home, we have energy management, appliance control, smart bathroom appliance, smart air condition, security system, smart door lock, remote control appliance, switching and on and off remotely appliance to avoid accident and save energy, refrigerators with LCD screen telling what is inside foods that about to expire, ingredients you need to buy and with all the information available on a smartphone application, washing machine allowing you to monitor the laundry remotely, and the kitchen ranging with interface to smartphone application allowing remotely adjustable temperature control monitoring or self-cleaning features, safety monitoring cameras and home alarm system making people feel safe in their daily life at home, intrusion detection system detection of window and the door opening and the violation to prevent intrudes, weather display outdoor weather conditions such as humidity, temperature, pressures, wind speed, and rail levels with ability to transmit data over long distance, energy and water use, water supply consumption monitoring to obtain advice on how to save the cost and resources. And also for consumers, the connectivity provided by Internet of Things could enhance their quality of life multiple ways, such as but not limited to energy efficiency and security at home. In the city, connected smart device will enable reduction of utility bills, outcasts, while also improving the human security via remote home monitoring. Smart home has become reality where all devices are integrated, interconnected via the wireless network. These smart devices have the potential to share information with each other. Smart city, smart government, smart manufacturing, mobile, smart digital citizens, smart transportation, smart security, smart home, smart farming, smart building, smart health, they are all this in smart city. In smart cities, application may be lighting, intelligent and weather adaptive lighting, street light, smart roads, intelligent highway with warning message and diversion according to climate condition and unexpected event like accident or traffic jams. Smart parking, real-time monitoring of parking space available in the city, making residents able to identify and reserve the closest available space. Waste management detections of rubbish level in containers to optimize the trash collection routes, garbage can and the recycle bin with RFID tags allow station staff to see when the garbage has been put out. In smart cities, the development of smart grid data analytics and autonomous vehicle will provide an intelligent platform to deliver innovations in energy management, traffic management, security by sharing the benefit of this technology throughout the society. IoT applications like in agriculture, smart agriculture, greenhouse control, microclimate condition to maximize the production of fruit and vegetables and its quality, composite control of humidity and the temperature level of alfalfa, hay straw, etc. to prevent hooch and other microbial sentiment, animal farming, tracking location and identification of animal grazing in open porch or location, big stable steady of ventilation and air quality in a farm, and detection of harmful gas from the excrements of spring care, control of growing condition of holstering and animal farm to ensure the survival and healthy, field monitoring, reducing spoilage and crop waste with better monitoring, accurate ongoing data obtaining, and management of the agricultural field, including better control of fertilizing, electricity, and watering. The task of irrigations can be automated with the help of Internet of Things. A set of sensors such as light, humidity, temperature can be used to continuously monitor the field conditions. The application of Internet of Things in smart health applications, smartwatches, fitness devices have changed the frequency of health monitoring. People can monitor their own health at regular intervals. Not only this, now if a patient coming to the hospital by ambulance, by the time she reaches the hospital, his health report is diagnosed by a doctor and the hospital quickly starts the treatment. The data gathered from multiple health applications are now collected and used to analyze different diseases and find this cure. Hospitals often use Internet of Things system to complete tasks such as inventory management for both pharmaceutical and medical instruments. So smart health application, wearable electronic devices are small devices worn on the head, neck, arm, toes, and feet. Current smart wearable devices include helmets and glasses for head, jewelry, collars, and for neck, watches, wristband, rings, arm, torch, clothing, and backspace, feet or socks, shoes. Wearable devices are also used for public safety, improving the first respondent response time during emergency by providing optimized routes to location or by tracking construction workers in firefighting vital signals at life-threatening sites. Smart energy applications also. Internet of Things to not only monitor the energy usage at the appliance level but also at the house level, grid level, or could be at the distribution level. Smart meters, smart grid are used to monitor energy consumptions. With a smart grid, energy distribution can be optimized. This grid also keep collection real-time and data which help distributing electricity efficiency and also reduce the outage. Internet of Things provide education aid which help in filling the gap in the education industry. Not only improve the quality of education but also optimize the cost and improve the management by taking into consideration students' response and performance. Through various sensors, IoT application in air, water pollution hazards. Through various sensors, we can detect the pollution in the air, water by frequently sampling. This helps in preventing substantial contamination and related disasters. The Internet of Things platform can be used to accommodate data related to specific geographical location using remote monitoring tools and perform analytics so that early warning of disaster can be found out. Internet of Things application development platform like is essential component of huge Internet of Things ecosystem that support connect all components within the system. It helps facilitate device management, handle hardware, software, communication protocol, collect, analyze data needs, data flow, and functionality of smart applications. Overall IT system include hardware, device, sensors, connectivity, route, gateway, Wi-Fi, satellite, Ethernet, software, user interface. Cloud hosting become widespread and generally appreciated method of developing and running various technology solutions. Internet of Things directly depending on Internet definitely benefit from all their advantage. Cloud computing, special cloud-based Internet of Things platform supports the Internet-based function. The application running maintenance, analytics, data storage, and security measurements. Some of cloud Internet of Things platforms like Google Cloud, Microsoft, Oracle Internet of Things, Huawei Cloud Core, IBM Watson Interface Things, Cisco Internet of Things are some examples. Thank you. This is all application of Internet of Things.